Welcome to the unit on quadratics, graphs of quadratics. The objectives for this session are to sketch the graph of quadratic functions. Recall that the solutions of the equation ax squared plus bx plus c equals 0, with a, b and c real and a not equal to 0, are given by the formula on your screen. Remember that in order to solve a quadratic, you need to put the equation in the correct format first. Take a look at this example. Pause the video and have a go. Press play when you're ready to view the solutions. In order to find the roots of f of x, let f of x equal 0. On the face of things, it seems that this equation is not a quadratic. However, if we look at this type of equation carefully, we can see that we can convert it or treat it like a quadratic. As you can see, we can replace x to the power 6 by x cubed squared and then leave x cubed as it is, as shown. Now we solve for x cubed. So x cubed equals minus b, we've plugged in the minus b, plus or minus square root of b squared, here's our b squared, minus 4ac is 4 times 8, all over 2a, which is 2 times 1. And tidying up gives us minus 7 plus or minus the square root of 81, all over 2, which equals minus 7 plus or minus 9, all over 2. Therefore, x cubed equals 1 or minus 8. And then cube rooting x cubed equals 1 gives us x equals 1, as shown. And cube rooting x cubed equals minus 8 gives us x equals minus 2. Let's remind ourselves what we need in order to sketch our quadratic. Consider the case where a is greater than 0. We require the x-intercepts, we require the y-intercept, the axis of symmetry, and the turning point. Now for the turning point, we need to consider the function in the form a times x plus p all squared plus q, and the turning point will be at minus p comma q. The graph of this function is a translation of the graph y equals ax squared by the vector minus pq. Now let's consider when a is less than 0. When this is the case, the quadratic is upside down, so to speak. However, we do look for the same things. We look for the x-intercepts, the y-intercept, the axis of symmetry, and the turning point. So let's summarize what we need in order to sketch our quadratic. We need to find the following points: the intersection with the y-axis, the intersections, possibly, with the x-axis, and the turning point at minus pq when f of x is equal to a times x plus p all squared plus q. Then we identify and label the above points and label the axes and join the points to form a smooth curve. Take a look at this example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's first find the intersection with the y-axis. When x is 0, what is y? We simply plug in x equals 0 into our equation as shown to give us that y is equal to 2. So when x is 0, y is 2. Now let's find the intersection or intersections with the x-axis. This time we put y equal to 0 or f of x equal to 0. This gives us a quadratic in the form x squared minus 6x plus 2 equals 0. And we simply use the quadratic formula in order to solve for x. So plugging in minus b plus or minus the square root of b squared minus 4ac all over 2a to give us x equals 3 plus or minus the square root of 28 all over 2. And then tidying up some more gives us x equals 3 plus or minus root 7. Now let's have a look at the turning point. The turning point is minus pq when f of x is given in the format a times x plus p all squared plus q. We can put it in this format by completing the square. Do remind yourself how to complete the square from one of the previous sessions. So when we apply this, we can see that y is equal to x minus 3 all squared minus 9 plus 2. And then tidying up gives us x minus 3 all squared minus 7. So our turning point is at x equals 3, because that is when x minus 3 all squared equals 0, and y equals minus 7. So now we have the key points for our graph. Let's now put these points together and plot them. So 0, 2 goes here, 3 minus root 7, 0 goes here, and 3 plus root 7, 0 goes here. The turning point is at 3, minus 7, which is here. And so we have our curve. Now have a look at example 3. Pause the video and have a go. Press play when you're ready to view the solution. So when x is 0, what is y? We have that y equals 5 when x is 0. When y is 0, what is x? Again, we have a quadratic. And solving, x equals 5 or x equals minus 1. As you can see, we use the completing the square method to solve this quadratic. And now identify the turning point. Again, using the method for completing the square, we have that y equals minus x minus 2 all squared plus 9. And now we can identify our turning point. So the turning point is at x equals 2, y equals 9. Now let's plot these points. 0, 5 goes here, 5, 0 goes here, and minus 1, 0 goes here. The turning point is at 2, 9, which is here. We've simply joined the points and plotted our curve. This brings us to the end of this session. If you have understood its contents, you should be able to sketch the graph of quadratic functions. Thank you very much for listening. In order to understand this topic in greater depth, Do attempt the exercises in your textbook related to it.